Hello everyone, lovely to see you again. Today we're going to talk about microplastics. Now, there's a lot of talk about microplastic everywhere, but how are we humans really exposed to microplastics? And once these plastics get into our body, do they really cause harm in our body? That's what I intend to talk about in the next few minutes. And a good place to start is to look at the various exposure routes, for humans. And by exposure routes, I mean, how do we get exposed as humans to microplastics? The alarming news of microplastics being found everywhere. By everywhere, I mean, microplastics have been found in testicles. It's been found in semen. It's been found in blood. It's been found in the brain. It's been found in placenta. Unimaginable places. Research, and I'm talking proper research, have found microplastics in this place. And the question oftentimes is, yes, it's been found in these places, so what? So what I intend to do today is to look at the various routes of exposure, look at how we can then use that knowledge to position ourselves better to reduce exposure, and also look at some health impacts of microplastics. So I think a good place to start is to answer the question, what are microplastics? Because it's easy for us to conflate plastics and microplastics. Now, the difference between plastics and microplastics is just size. So when plastics are in sizes less than or equal to 5 millimeters, we refer to them as microplastics. Of course, when it goes down, we then start talking about nanoplastics. Again, all function of size. And just to create a clear understanding of what we mean by 5 millimeters. Now, an average straw, your average straw, the diameter. So if you look at your straw, I'm looking at here, will be approximately 5 millimeters. And so that gives you an idea. Everything from that size downwards, we refer to them as microplastics. Now, what are the ways of exposure? Broadly, we have 3 ways of exposure, and that's inhalation, as we breathe in, the microplastics we breathe in, ingestion, the microplastics we consume either through food, water, or even food packaging, and the last or the third route of exposure, which a lot of people might not be familiar with, is dermal exposure. So microplastics can actually pass through your skin, my skin, into our system. So that's a route of exposure. Now, looking at these individual routes, let's look at inhalation for one. There's so much microplastics in the atmosphere that we are able to breathe in loads of microplastics. Now, for some people, I know you would struggle to imagine 5 millimeters of microplastics flying around. But as the size begins to go down, microfibers, for instance, as the size begins to go down, then it becomes buoyant, or it becomes airborne, and then we are able to take that in through inhalation. Inhalation also can be broken down into indoor exposure and outdoor exposure. Now, it will shock you to know that actually, because on the average, most people spend approximately 90% of their time indoors, the highest exposure through inhalation actually occurs in-house, indoors. The exposure outdoors is often less than what happens when you are indoors. And that's easy to explain. Most carpets are made of plastic-containing materials. Our fabrics, mostly microfibers, contain plastics. Almost everything in houses, offices, and domestic areas contain plastic. So it is clear to see that actually indoor exposure is more of a problem than outdoor exposure. Now, when we talk about microplastics, it's good for us to emphasize that there are different types of microplastics. There are different shapes. There are different compositions. All of these factors affect all of these things we talk about. So when we measure microplastics in the air, people inhale, oftentimes there'll be variation based on type, because the type of plastic would affect the density of the plastic, and that also affects whether it would be able to float in the air or not. So if I use the term microplastic, understand that there's a broad range of types, sizes, shapes in that conversation. So bear that in mind. Some research have shown that approximately 130 airborne microplastics could be inhaled by an individual per day. That's the average, 130 tiny particles of microplastics. For indoor environment, we're looking at approximately 1,583 microplastics per meter cubed. Now, meter cubed, so the approximate length of your guitar, your average adult guitar, is approximately 1 meter, right? So when we're talking about 1 meter cube, imagine a container that is 1 meter this way, 1 meter that way, and 1 meter this way. So that's a meter cube. Now, in that size of space, research has shown that indoor, you can have as much as 1,583 microplastics. Now, if you look at this screen, this is a screen that I recorded in an office. And these tiny particles you are seeing on this screen are actually mostly, some of them are dust particles, but considering the fact that the office I'm recording has carpets that are made from plastic materials, a good bunch of what you're seeing on these screens would be microplastics. So most of them would be airborne before settling. And so as you step into this office and breathe in, a lot of these plastics go into your body. So 1,583 microplastics per meter cubed. Now, if we contrast that to an outdoor environment, we're looking at approximately 224 microplastics per particle per meter cubed if you're looking at an urban area. Again, this would also change if you're talking about a rural area. In rural areas, we're looking at approximately 103 microplastics per meter cubed. So you can see variations. And one of the reasons I'm saying this thing is this knowledge would most likely equip you to kind of avoid microplastics if you're someone who wants to really avoid them. So, for instance, you could choose to live in a rural area if exposure by inhalation is your major concern. Then you choose to live in a rural area instead of an urban area. You also choose to spend more time outdoors than you spend indoors. And again, if you spend time in the woods, even if you're in an urban area, if you spend more time in the park, in the woods, obviously there will be less of microplastics in that environment. So that's inhalation. Now, if we take it beyond inhalation and look at ingestion. Ingestion actually is one of the major routes of exposure for humans because from the food we eat, the water we drink, the food packagings that we use in all the things that we eat and consume, all of these things most times contain microplastics. But the most concerning route of exposure as far as ingestion is concerned is seafood. And this is not surprising because the ocean as it is now is like a hub for microplastics. Salts that we get from, oceans and lakes and all of that, a good number of the salts people consume contain microplastics. Now, research has shown that up to 102,000 particles of microplastics per meter cubed is what we can be talking about when we're looking at the ocean. 102,000 microplastics per meter cubed. Remember, I've just said a meter cubed is approximately, so imagine a container, guitar length. In that space, in your typical or average ocean, you would have approximately 102,000 microplastics. Now, these plastics end up fish and other animals that we like, crabs and all these things we eat, mistake some of those plastics for food and they consume them. And when we eat this food, these seafoods, oftentimes we eat the plastics along. It's been shown by research that the average yearly microplastic intake by an average family from just fish, I'm not talking of other forms of seafood yet, I'm just talking about fish alone, is approximately 8,323 particles per year. So, ingestion is a major concern. Now, the third and the final route of exposure is the dermal exposure. And this basically happens when we use things that contain microplastics. Now, microbeads are often incorporated in face scrubs and all of that. Some toothpastes contain some form of microplastics. Some of the cosmetics people apply on their skins contain some form of microplastics. And so when those are used, they serve as route of exposure. And those microplastics, oftentimes, depending on the size, I think the research has shown that things in the range of 40 micrometers would be able to penetrate the human skin. Now remember, micrometers, if you take 1 millimeter and you divide it into 1,000 places, then you're looking at a micrometer. So 40 micrometer would be able to penetrate the skin. Another way to picture that size I'm talking about is, so your average hair, if you look at the diameter, again, I'm looking at this part of the hair, is approximately 60 to 120 micrometers. So 100 approximately, we're looking at that hair size. Now, if you cut that into half, it means microplastic of that size would be able to penetrate the human skin. And so that's another route of exposure. But yes, this explains why we have seen microplastics in almost every part of the human body, because once the microplastics get in, they are able to travel through barriers. So they are able to translocate, that's the word, to move from one place to the other. And so they end up in the liver, in the lungs, in almost everywhere in humans. But once these plastics go in, the big question is, yes, they are everywhere. Do they cause any health problems? Are they toxic? Now, the truth is, research looking at the impact of plastics on humans are a bit challenging for ethical reasons. Imagine tying someone on a chair and dissecting them to check if there's microplastics. But there are several other ways that we can test to see. One way scientists have done that is to use rodents, rats, mice, to test. And exposure experiments have shown that these microplastics have been correlated with a lot of health impacts. And what that means really is you take some of these mice, expose them to certain kinds of microplastics, sizes, types, shapes, and all of that, and you see the impact on them. And a lot of things have been associated to microplastics. For humans, we don't have conclusive results to say when humans take in so and so amount of microplastics, it results in this and that effect. But from the results seen from those experiments, we can say that microplastics have adverse effects on several parts of the human body, ranging from digestive system, problem with the digestive system, respiratory system, nervous system, reproductive system, both male and female. There's been a lot of correlation of the effect of microplastics. And so, instead of using yourself as an experiment and saying, well, it doesn't matter, my recommendation would be to try as much as you can to avoid exposure to microplastics. And at this point, I think it would be fair to say that's a very difficult task. For instance, we've just talked about dermal exposure. The human skin is like the largest organ in the human body. We're looking at between 1.5 to 2 meters squared. That's the area of the human skin. So now, that's a lot of space to try to protect and cover. You wear clothing that contain microplastic. So it's almost impossible for us to separate ourselves from microplastics completely. But what we can do is to use the knowledge that I've just that we have now to minimize the exposure. So seafood, for instance, maybe we'll be more careful. And if you must eat fish, you insist on eating just the flesh. But again, that's not to say science has not shown that the microplastics are actually able to pass through the flesh. So, but you would reduce your exposure significantly by throwing away everything in the in the guts, in the intestine and all of that. If you get rid of all of that, you would most likely be reducing your exposure to a significant extent. Something else you could do using the knowledge we've acquired so far is knowing that indoor spaces would have more microplastics than outdoor spaces. Maybe spending more time outdoors would be helpful. And if you have the ability to control what you put in your room, avoiding things that contain plastics would be another way to reduce your indoor exposure. Now, I've just talked about an average adult spending about approximately 90% of their times indoor. Imagine infants. They spend 100% of their time indoors. With this level of exposure, that's a scary thing to think about. And so if you are in that situation, the less plastic containing things you have in your house, the better for you. So those are areas and ways. Another way to look at it again is food packaging. Food packaging is a very crazy one because it's not just the fact that for instance, if you have meat packaged in a plastic container, the rubbing or the wear and tear as a result of the contact between the meat and the plastic packaging releases tiny micro and nanoplastics on the meat. That's one. The other challenging thing is the chemicals that are added to these plastics during manufacture have a way of moving from the plastics into the things they're packaged with. So, one way to reduce that exposure is to avoid things that are packaged with plastics. I think industries are beginning to move in that direction now because people are becoming aware of these routes of exposure. And that's one of the things I'm hoping to achieve with this video, help people understand the routes of exposure. Some people are so bothered about things like drinking water, but the average number of microplastics you stand to expose yourself to by taking a direct cup of water, of tap water, is very, very low. And some would say tap water is bad. I'll take bottled water. Do you know that science has actually shown that people who take plastic bottled water instead of tap water are exposed to approximately 90,000 more particles? I'll repeat that. So if you think you're escaping dirty water by refusing to take tap water and then you land on your plastic bottled water, you would be exposing yourself to 90,000 more particles than someone who takes direct tap water. And that's because the purification process that tap water goes through, I don't know of every country, but like in the UK, it reduces more than 90% of microplastics are actually removed by the treatment systems we have here in the UK. The big question then becomes, most of those plastics are removed from the drinking water. Where do they end? But the drinking water you get, as far as microplastic goes, is fairly safe. And if I'm talking of this amount of exposure from inhalation, I think instead of being bothered about drinking water, there are more things to be bothered about. But that's a conversation for another day. So all these microplastics are in us and they cause all this harm. What can we do? Like I've said, apply the knowledge you've acquired. Number 2 is the simple waste hierarchy is something we can always rely on. So it classes the things we can do in your, pyramid, upside down pyramid shape, where the best solutions are up here and the least preferred options are down here. And so if you look at that pyramid, topmost is prevention and reduction. So if you can prevent contact with plastics, making sure you buy things that do not contain plastics, that's your best solution. The second best solution is, it is practically impossible to stop contact with all forms of plastic. The second best becomes recycling, reusing, and preparing things for recycling, basically. So you buy a plastic bag, instead of disposing it, use it for as many times as you can, because it definitely ends up somewhere. And what goes around always comes around. So If you can't reuse them, then you recycle. Take it to your local recycle center. Now, recycling, let's be very careful because some things cannot be recycled at home. So check carefully to be sure that what you're recycling is being recycled appropriately. And so the last and the least preferred option will be things like disposal. So if you cannot avoid it, if you cannot reuse it, if you cannot recycle it, then you can dispose of it with hope that it will be properly disposed when we dispose it, with hope that it will be properly disposed. So, I've talked a lot about plastics already. I've bored you with loads of statistics and numbers. But the core or the gist of what I'm saying is, microplastics are everywhere. We have several routes of exposure. They most likely or most certainly cause several health concerns. We can do a lot of things to help ourselves. So, why not leave in the comment section what you are currently doing or what people you know do to reduce their contact or their exposure to microplastics. And if you have any questions specifically, please feel free to ask and I'll try my best to see if I can answer. But thank you very much for hanging on for this long. It's a long chat, but hopefully you've picked up a few things that you would use going forward. So thank you very much for watching and see you again soon. Cheers.